This is RobertPagan, Lab M03, Lab 2 on constant velocity. For my observation, I took a video of a moving penny board and used Tracker to analyze it and then modeled it with VPython. Our main result was that when we set fnet equal to 0, the model predicted observations and information in Tracker well. In Tracker, we looked at the video after kicking off and before stopping so that there were no external forces accounted for. And I started the center of mass at as close to the origin as possible just to make it easier and to make the data easier to look at. I made the plus x direction to make it easier to relate to the coordinate plane in our graphs. And I marked the center of mass below my right foot, close to the center of the board as my average position. I measured the board with a calibration stick and used 0.5 meters to scale the data. The time between frames was 0.033 seconds, and we looked at a clip of 2.302 seconds. And we put this information into VPython. And so here's what we did. We made the ball, the mass of the ball, 1 kilogram, approximately 2.2 pounds. And the initial position was really close to the origin, 0.018 meters. We had to calculate the initial velocity, and we did this using the formula delta x over delta t. And our final position was 5.068. Initial was 0.018. And delta t was just 2.302 because we started the clip at 0 seconds. So we found our initial velocity to be equal to 2.1937 meters per second, and we put this into Python, into our velocity vector, and I made delta t 0.033. That way, when I exported the data, the tables were directly comparable, the Python table and the Tracker table. And so when we ran this program, we saw, if it comes up, yeah, it's being glitchy because of the screen recording going on at the same time. But the ball moved in linear motion at a constant velocity, as represented here by this straight line. Oh, and also, for the other part of our program, we used Newton's second law to determine what fnet was going to be. So v was constant. That was the whole point of the experiment. The penny board was ridden at a constant velocity, so final velocity minus initial velocity was going to equal 0, which means the right side of the equation, fnet over m times delta t, had to equal 0 as well. We knew mass was not equal to 0, and we knew delta t was not equal to 0. Therefore, fnet had to be equal to 0. And that was just shown in the VPython simulation. We then graph the data, and the blue squares are data from Python, the red triangles are data from Tracker. You see that there is a slight disparagement towards the middle, and this I think might have been the fact that the camera I used, a GoPro, has somewhat of a fisheye effect, and so towards the middle, I think the size of the board, as seen by the lens, changed a little bit, and so the distances were a little bit off. But it really is a close representation of what actually was simulated by Python, which is probably the most accurate. So that was definitely cool. So now we look at what if. What if there was a different choice of origin? Well, we're going to pull up Tracker here. If the origin was changed and say this was the third quadrant, most values will be different. Initial position will be different, final position, velocity would be negative, but F net would still be 0 because velocity would still be constant. If you looked at the same quadrant but with the motion starting from a different location, say right here, everything would be the same except final and initial position, and they would still have the same difference, yielding the same velocity. So what does this all mean? Is it possible for you to say how many pushes and pulls are added together to give zero net force in the case that you observed? We know that the ground is pushing up with the same force that gravity is pushing down with. Aside from that, we haven't studied angular momentum enough to know what horizontal pushes and pulls are going on with the wheels on the penny board. So this concludes the lab, and I guess in future classes we'll be able to answer those questions.